aroused,
Yes.
laser.
As an amateur, since my retirement, I'm living in the near Nuremberg in Germany, and then I observe mainly earlier stars, and I asked myself, what can data mining help to find interesting objects? I will only speak about the most best known surveys which are accessible via BSX. The oldest one is a northern survey of variable stars. It's the oldest one. It's important because it's only operational a little more than 1 year, but it's important because it gave the way the next service will go on. Let us have a look at some light curves. For example, you have here a relatively bright earlier star, and you see the general shape of the light curve, and we can guess that this star pulsates relatively regularly, and that the light curve doesn't change much. But in other cases, here in this star, you have clearly Blaschko effect, and you can see that this survey doesn't give much information. We need more measurement points, and when the magnitude goes down, the stars becomes fainter, the light curve is very approximate. We do need other sources to have more information on these stars. The last two are very interesting because they are near together in the field of my camera. It's a rare case where two early stars are very near in the same field, and one of them, the 338, has in the literature there is a Blaschko period from 161 or 349 days. I found a little bit other periods. We shall see how I came to this conclusion. And the other pulsates regularly. There is no change in the light curve and in the period. Well, let us have a look now at the Catalina survey. And I will take the example I have. For the first one, Catalina is not present everywhere. There are voids. And you must also be aware that for a very bright star, relatively bright star, there is saturation, heavy saturation. Because the instrument use were of the 1 meter class. But for stars fainter than 12, approximately 12.5 magnitudes, Catalina is very useful. Generally, in the average, Catalina gives 300 measurement points spread over 6 years. That's not much, but if these points reduced with a fundamental period gives a clear-cut light curve, you can assume that the star pulsates very regularly. Whereas its neighbor, B33979, shows the clear-cut Blaschko effect, and it helps, Catalina helps to choose, to establish a ranking from very interesting, like this one, to less interesting, like this one. The next? Ah, yes. And I asked also myself if we could not extract more information about the star, not only to have a first impression of the shape of the light curve. So I decided to try to cut the light curve and to preserve only the brightest points, and I declared them as approximate maxima. They are not really at the maximum, but they are near it. And so you can fill up an empty O minus C diagram. It works. Here, the yellow points are these approximate maxima I derived from the Catalina survey. In the GEOS database, Relay database, only these points, these maxima are registered, and this one is my recent maximum, and as you see that this star doesn't change, period, and the shape of the light curve is also constant. In the other star, the other one, the neighbor, has more problems because the O minus C diagram in the GEOS database contains only the old photographic maxima derived by Kuno Hofmeister, and there's a large gap. And then in the GEOS database, here these points are here, and these points I derived them from SuperWASP data, whom I will describe a little bit later. And this is the recent maximum I got. And you see clearly there is an indication that this star has a rapid period variation. But due to the large gap here, we are not sure. We are losing the epoch counting. I don't know. This is not very logic. This sounds a little bit more logic, but we cannot reconstitute the history of the period variation. The work of Sonnenberg is lost. It's a pity, but we cannot change it. So, yes, now let us have a look at SuperWASP, very well known. Thank you very much to Mr. Detcher to have hosted this one. Why not? Yeah, nevertheless, I thank you very much to have hosted this only one, the one and only public release. SuperWASP is still working, but you cannot expect to get another more recent public release. This is only one. But please don't throw this data away. I'm still using it. Never. Next. Yes. There are more possibilities. This data has numerous drawbacks. For example, you get at first 15,000 measurements. Oh, very good. But if you filter out, you can easily reduce the 15,000 to less than the half of that. It must be severely cleaned. The data must be severely cleaned. But what can you expect with a little bit with some change here? Oops. Yes, we have also here our area representing signs of a glacial period, and I guessed maybe that there is a 150 days period. Not very convincing, but maybe it is possible. There must also one major drawback from the superWASP data is that the magnitude information gets lost, because from one measurement series to the other, the mean level varies. But nevertheless, the temporal information can be used, because one of these vertical lines of points, the measurement points, are results from a whole night. So that you can extract from one night, you can extract the timing of a maximum. And this is what I tried here. These red points are the maxima I extracted from all the data here. Well, with some difficulties, we can see my 150-day Blaszko period, but it's not very convincing. Well, the superWASP data gives sometimes some very interesting pictures. Next one? No. Ah, yes. For example, this one. It has no general catalog designation. It's only the two mass or another. It is a relatively new, unknown area star. It's absolutely crazy. Here, the amplitude goes on, an enormous amplitude, and then the amplitude goes down. Very interesting indeed. It's a prime, for me, a prime target. And so there's superWASP data can give some surprises and really help to choose interesting objects needing more investigation. Well, let us have a look at other sort of stars. superWASP is very useful for rapidly, here is a very short period, and there the quality is excellent. and the star is relatively bright. For the other stars, with longer period, I don't recommend it. For example, here a friend of mine discovered this eclipsing star and asked me to look at the surveys to get more information. And SuperWASP gives something very curious. The green and red measurements are simultaneous from two different cameras. And look here, very curious. I have never seen that. The green points shows that there's a secondary minimum, and simultaneously, at the same time, the red points doesn't show any secondary minimum. Very curious. For long period stars, this data is totally is not useful. This should be a delta Kephi star. Please don't use SuperWASP data for long period stars. Here also a long period eclipsing binary. No. Sorry, you must use other surveys. And yet let us now go to the others survey. And I had a look at some light curves from northern stars, and the points were very few and very noisy. But northern stars is not the prime target of others data. It gives more information on southern stars. But this publication attracted my attention, and from the beginning on I was skeptic, because they, with this very noisy data, they found numerous Blaschko periods. Well, let's have a look at it. Here I rearranged the table of the Blaschko period they found, and from the shortest to the longest, and they claimed to have found a very rapid Blaschko period with only 5 days. You must be, I was very skeptic. Then another star with a claimed 6 and so on days a Blaschko period is in reality a low amplitude Veuma star. Then another star with a long, very long Blaschko period, around 340 days, with such few points, with a very noisy light curve. Attention, 340 days are very near the 1 year pseudo period. Be cautious. But another star was for me astonishing. The Beovuis, very south star, shows a period of approximately 10 days. And with this light curve, this period is real. For with SuperWASP data, I saw the greatest amplitude I ever seen in the changing amplitude due to a Blaschko period. This is SuperWASP data, in the distance of 10 days, exactly, the Blaschko period they found, and the amplitude of this RC star is maximum, and 5 days apart, the oscillation disappears quasi. Yeah? Also, there is some, also all the derived maxima from superWASP gave a perfect Blaschko cycle. Well, let us see a rapid look at my results. In green, here you see it better here. In green, the Blaschko period they found in the catalogue compared with the periods found through superWASP and others SN data, and the red ones are artifacts. Also, please don't overinterpret the data given by such surveys. Rapidly, the most recent one and my absolute favorite, I work very every day with it, is ASAS SN. The difference to other surveys is that the older surveys, the database is fixed. Yeah, you can extract data from one star, but this database is fixed. But the ASAS SN is expanding. You can expect new data. Yeah? When you make when you put in the vector ascension and declination of the star, then you must be controlled that you are a human operator, and then you push the button here, and then you can have some tea time for the server of this ASAS calculates for you every time new. They reduce every time new, and this is some time, 15, 20 minutes, and then it gives data in return. Sometimes the server tells you that it is overloaded, try it later again. Well, this can be done, and here the result. And you see every observation season, 2019, 2018, 17, and so on. Very interesting. Huh? And very recently, the magnitudes are B magnitudes derived from APAS magnitudes from the AAVSO. And very recently, they gave also colors in another color, measurements in another color, G prime magnitudes. Here, the classical B magnitude with 100 nanometer, and here the G prime, which overlaps somewhat with the V. I haven't understood why they did that. It's not separated. The two bands are overlapping. Why they did do that, I don't know. Well, this to come to an end. This is an example. B magnitudes, and now recently the G prime magnitudes. And as I showed formally, also you can derive approximate maxima and fill up the homeostatic diagram. And in the case, and if the star presents a Blaschke effect, you can also take period 04 and get and hope to get Blaschke period. But you can see here that there may be a very long period, Blaschke period. And this star is one also of my favorites. Thank you for